Hello, hi everyone. This is Dr. U. Raghavinder, Assistant Professor of Chemistry, MVS Government Degree and PG College, Mahabub Nagar. Today I want to discuss about part 3 of amines. In this video, I want to discuss about the part 3 of amines. Till now, I developed two videos on amines, that is part 1 and part 2. In part 1 of my video, I explained about the introduction, classification, nomenclature, as well as preparation methods of amines. In part 2 of amines video, I explained about the physical properties of amines such as solubility, hydrogen bonding, physical state, as well as basicity of amines. And also I discussed about the use of quaternary ammonium salts as phase transfer catalysts. Okay, fine. Next, in this video, I want to discuss about the chemical properties of amines. Chemical properties of amines. In chemical properties, the chemical reactions of amines is first one is alkylation, acylation, the carbylamine reaction, and the next one is Innsberg separation. And also I want to discuss about the reaction of aliphatic as well as aromatic amines with nitrous acid. If you observe the chemical reactions of the amines, generally the chemical reactivity of amines depends on the availability of electron density on nitrogen atom of amine. That is, the chemical reactivity is mainly due to the lone pair of electron present on nitrogen atom of amines. Due to this presence of lone pair of electrons on nitrogen atom of amines, generally they act as bases and also act as good nucleophiles. That's why they undergo nucleophilic substitution as well as addition reactions with suitable reactants to form desired products. Okay, fine. Next, the first one is the first chemical property or chemical reaction of amines is alkylation. Alkylation is nothing but substitution of one or more alkyl groups on a reactant molecule, generally known as alkylation. Generally alkylation done by using alkyl halides. In the case of amines, alkylation is nothing but a reaction of amines with alkyl halide which produces alkylated amines, generally known as alkylation of amines. In alkylation, generally the amines, as we discussed in the previous slide, amines acts as nucleophiles and undergo nucleophilic substitution on alkyl halide to replace halide ion. That is, finally alkyl group of alkyl halide substituted on amine. Okay, next, here in the case of amines, there are three types. One is primary, secondary, tertiary amines. So primary amines generally undergo reactions with primary halides to form as to form a salt, alkylated ammonium salt, which after that undergo deprotonation to form corresponding secondary amine. That is, reaction of primary amines with primary alkyl halides produces finally secondary amine. Here the secondary amines produced in the first step act as best nucleophile than the primary amines, so they further undergo reaction with one more alkyl halide to form corresponding tertiary amine after deprotonation of the intermediate salt. This tertiary amine further act as nucleophile and react with one more halide to form finally ammonium salt. Quaternary ammonium salt. So, reaction of primary amine with primary halide undergo a series of chemical reaction to form quaternary ammonium salt as a final product. So, in this alkylation of amines, we get different products. It may be secondary, tertiary, finally quaternary ammonium salt, as we discussed in the preparation method of amines in part 1 of amines, where the ammonolysis of alkyl halides, it is similar to that of ammonolysis of alkyl halides. In ammonolysis, the reaction started with ammonia. Here in alkylation, the reaction started with amines, maybe primary, secondary. Here the only in the case of alkyl halides are also three types: primary, secondary, tertiary, where the halide or halogen atom is attached to whether it is primary or secondary or tertiary carbon of the corresponding alkyl halide. So there are also three types. Among these three alkyl halides, only primary, in some cases secondary halides undergo alkylation of amines through nucleophilic substitution reaction method, that is mainly through SN2 type reaction. In the case of alkyl halides, may also be aromatic in nature. If you take aromatic alkyl halide in alkylation, they don't undergo alkylation reaction because because of their less reactivity. That is, in the case of aromatic halides, there is a partial double bond in between the carbon atom of the arene ring and halogen atom. That's why they shows less reactivity, so they don't undergo alkylation reaction with amines. Okay, fine. Next, here what is the reactions are undergoing in the alkylation reaction. Here, as we discussed in the previous slide, the primary amine undergo reaction with alkyl halide to form secondary amine. This secondary amine further react with alkyl halide and produces tertiary amine. This tertiary amine further react with alkyl halide to form finally a quaternary ammonium salt. Here the reactant, that is alkyl halide, must be primary or it may be methyl halide. Majorly the primary halides undergo easily alkylation reaction with different amines. This reaction is generally undergoes through SN2 type mechanism. You take specific example, for example, it is alkyl halide undergo reaction with ammonia, forms a primary amine. It is ammonolysis. It is generally 1, 2, 3, 4 is N-butyl bromide reacts with ammonia to form N-butyl amine. This N-butyl Here the propylamine, the other one is propylamine, undergo reaction with alkyl halide, that is methyl chloride, to form methyl N-propanamyl. The case of aromatic amines, if you take amine, that is aniline, to undergo reaction with halide, alkyl halide, to form here 2 moles of alkyl halide interacting with the aniline molecule, then the 2 hydrogens of the NH2 group replaced by 2 ethyl group. So we get aniline diethyl aniline. If you take benzyl amine, it is not aromatic, it is an aliphatic because the amine group is attached to aliphatic side chain. So it is an example for aliphatic amine. That is the benzyl amine react with excess methyl halide, then we get benzyl trimethyl ammonium iodide, that is we get quaternary ammonium salt as a final product. Okay, this is all about alkylation of amines. Here in alkylation, the points you should remember in alkylation is it is generally one type of nucleophilic substitution reaction. The specific method is which undertake in this substitution reaction is bimolecular substitution reaction, that is SN2 type reaction. Only primary alkyl halides and methyl alkyl halides undergo alkylation or in the alkylation of amines. Amines may be aliphatic as well as aromatic, but the alkyl halide must be aliphatic only because the aromatic halides don't undergo alkylation reaction due to their less reactivity. Okay, fine. Next, the next one is acylation reaction of amines. Here in the case of acylation is nothing but alkylation means substitution of alkyl group. Here acylation means substitution of acyl group on a particular compound or molecule. Here acylation is generally carried out by taking acylating agents. The main acylating agents are acyl halides, that is acid halides, as well as acid anhydrides. Acid anhydrides as well as acid halides are the best acylating agents used for acylation of specific molecules. In the case of amines, the primary and secondary amines generally undergo acylation with acid halides, or that is mainly acid halides or acidic chlorides, or they may also undergo reaction with anhydrides such as acetic anhydride to form corresponding amides. In acylation of amines with acid halide or acid anhydride, we get corresponding amide derivative. Here the reaction proceeds through nucleophilic substitution of amine on carbonyl carbon of acid halide or acid anhydride in the first step. Then we get a addition product, nucleophilic addition product. This addition product in the next step undergo uh, loss of some small molecules to form corresponding product, that is amide product. That is the if you observe the overall acylation reaction, acylation is an addition elimination type reaction. Here addition is generally nucleophilic addition and followed by elimination is observed in the acylation of amines. Here only primary and secondary amines undergo acylation, but not the tertiary amines, because in acylation the hydrogen of the primary and secondary amines are replaced by acyl group or substituted by acyl group, that is RCO. Acyl group is RCO is acyl group. So, in the case of tertiary amine, due to lack of hydrogen, don't undergo acylation with acylating agents. If you observe the reaction, here the reaction is generally it is nucleophilic addition elimination type reaction. The primary amine undergo acylation with acid halide, acid chloride to form N-substituted amide. The secondary amine undergo the same type of acylation reaction with acid chloride to form NN disubstituted amide. But the tertiary amine don't undergo acylation with acid halide due to lack of hydrogen. So there is no reaction with tertiary amine. There is no acylation with tertiary amine. In the case of aromatic amines also, they also undergo acylation with acylating agents such as acid halide or anhydride. Here, for example, the primary amine, that is best one, is aniline. C6H5NH2 aniline undergo acylation with acetic anhydride to form N-acetyl, or sorry, it is N-phenyl acetamide. It is acid derivative, so it is N-phenyl acetamide. Here the amine, secondary amine, undergo reaction with acid chloride to form corresponding amide derivative. Here the NN dimethyl aniline also undergo reaction with acetyl chloride. Sorry, here it does not undergo reaction to form corresponding amide because this NN dimethyl aniline don't have any hydrogen. So due to lack of hydrogen, don't undergo any acylation reaction because it is a tertiary amine. So it don't undergo any chemical reaction, acylation, or any acylation reaction. Only in acylation, only primary and secondary amines undergo acylation with acylating agents such as acid halides and acid anhydrides, produces their corresponding amide derivatives. Okay, this is all about the acylation reaction. The reaction is type of reaction, that is nucleophilic addition followed by elimination type reaction, addition elimination type reaction. Okay, fine. Next, third one is the carbylamine reaction. Here, what is the carbylamine? Carbylamines are generally the other name for isocyanates. Isocyanates are, they are isomers of functional group isomers of cyanates. The cyanide general formula is RCN. Isocyanate general formula is RNC. That is, the functional group is NC is isocyanate functional group. CN is cyanide functional group. Cyanide also known as nitriles. Isocyanates also known as carbylamines. Carbylamine reaction. Here in carbylamine reaction, what is carbylamine reaction? Carbylamine reaction is nothing but it is conversion of primary amines. Conversion of primary amines. Here the primary amines, they may be aliphatic or aromatic, both. That is aliphatic as well as both aromatic, both primary amines converted into corresponding isocyanates on treatment with chloroform in the presence of alkali solution. That is conversion of primary amines into corresponding isocyanates on treatment with chloroform in the presence of alkali solution, generally known as carbylamine reaction, because the products here in this reaction are isocyanates, which are also known as carbylamines. So the reaction named as carbylamine reaction. If you observe the reaction, the other one is, if you observe the smell of the isocyanates or carbylamines, Generally they have unpleasant smell or foul smell, and they also are very fineness substances. So based on their unpleasant smell or fineness nature, we can identify them. So the carbylamine reaction used as a best test to identify primary amines of aliphatic as well as aromatic, that is to identify primary amines. Carbyl amine test is generally used. So observe the reaction. Here the reaction is this one. Here the primary amine RH2 undergo reaction with CHCl3 chloroform, the presence of base, that is alkali, that is potassium hydroxide or sodium hydroxide, the presence of solvent, maybe ether or anyone. Then we get corresponding isocyanide or NC. Isocyanide functional group is NC, so we get corresponding isocyanide or NC. These isocyanates generally known as carbylamine. So the reaction is known as carbylamine reaction. They have unpleasant or foul smell. There is a difference in between isocyanates and isocyanates. Isocyanates are RNC. Isocyanates is RNCO. If you observe the examples for carbylamine reaction, if you take aliphatic primary amine, for example methyl amine, undergo reaction with chloroform in the presence of base to form methyl isocyanide CH3NC. It is different from methyl isocyanate MIC, MIC, methyl isocyanate, not cyanide. MIC is methyl isocyanate, which is released during the burst of the pesticide industry in Bhopal in 1983. So it is a very poisonous gas. Methyl isocyanates also poisonous gases. Here the carbylamine is methyl isocyanate. If you take other example, that is dimethyl amine with chloroform, then we get no product, that is only primary amines undergo reaction with the chloroform. The secondary amines don't undergo any reaction. In the case of aromatic amines, the primary amine is best example is aniline, where the NH2 group is directly attached to benzene ring, undergo reaction with chloroform in the presence of base to form phenyl isocyanide C6H5NC, phenyl isocyanide. So carbylamine is nothing but conversion of aliphatic as well as aromatic primary amines into their corresponding isocyanates on treatment with chloroform in the presence of alkali solution. Only primary amines. The condition is only primary amines undergo this reaction. Okay, fine. Next, the next one is Innsberg separation method. Innsberg separation or Innsberg separation method. Here, as we discussed in the preparation method as well as in alkylation of amines cases, generally in our ammonolysis preparation method or alkylation of amines, we get a mixture of amines, primary, secondary, tertiary, and quaternary ammonium salts present in the reaction mixture of alkylation or ammonolysis reaction. So you get mixture of primary, secondary, tertiary as well as quaternary ammonium salts during the course of chemical reaction. How can we separate them from their mixture? If you want only one amine from their mixture, it is essential to separate the desired one from the mixture. In order to separate the desired amine from their mixture, we have to choose some separating methods. Among them, the best one is Hinsberg separation method. Here, Hinsberg separation method is generally used to separate amines from their mixture. The amines mixture generally obtained on alkylation of primary amines or homoanalysis of alkyl halides. Here, the benzene sulfonyl chloride is generally known as Hinsberg reagent. In order to separate the amines or the desired amine from their amine mixture, we have to react the mixture with a suitable chemical reagent. Here, the chemical reagent used to react with the mixture is benzene sulfonyl chloride. Here, the benzene sulfonyl chloride, generally named as Hinsberg reagent, which is used in the Hinsberg separation method. So, by using Hinsberg reagent, that is benzene sulfonyl chloride, we can separate the mixture of amines. If you take the mixture of amines which contains primary, secondary, tertiary, and quaternary ammonium salts, which obtained on the homoanalysis of alkyl halide. It contains four types of molecule: primary, secondary, tertiary amines, as well as ammonium salt, quaternary ammonium salt. In order to separate this mixture, we have to follow some series of steps. In the first step, we have to add some cold HCl solution to the mixture of amines. Then the quaternary ammonium salt enters into the HCl, that is acid medium. Then the reaction mixture forms two layers. One layer is organic layer, that it is mainly ether solution. Generally, the reaction carried out in the presence of ether, ammonolysis reaction. So, the organic layer is ether layer. The other one which obtained due to the addition of HCl is acid layer or aqueous layer. In acid layer, generally it contains quaternary ammonium salt. Due to the salt nature, it enters into aqueous cold HCl solution, into cold HCl solution. Then we have to separate these two layers, aqueous acidic as well as organic layer, by using separating funnel. From the acidic layer, we can separate the quaternary ammonium salt. The ethereal solution, that is organic layer, contains primary, secondary, as well as tertiary amines mixture. So we have to separate them. If you add Hinsberg reagent to the ethereal solution of amines mixture, which contains primary, secondary, and tertiary amines, then only primary and secondary amines undergo reaction with Hinsberg reagent to form corresponding benzene sulfonamides. On reaction of primary amine with benzene sulfonyl chloride, that is Hinsberg reagent, we get N-alkyl benzene sulfonamide. On reaction of secondary amine with sulfonyl chloride, we get N-dialkyl benzene sulfonamide. That is, only primary and secondary amines react with benzene sulfonyl chloride, that is Hinsberg reagent. So the two, that is primary and secondary amines present in the ethereal solution. The tertiary amine, which also present in ethereal solution, don't react with the Hinsberg reagent due to lack of hydrogen. This reaction, that is reaction of Hinsberg reagent with primary and secondary amines, generally it is one type of acylation reaction, where here it is a type of acylation reaction, acylating type reaction. Here the tertiary amines don't react with the sulfonyl chloride or Isberg reagent. Only the two first and primary and secondary amines react with the Isberg reagent. So the ethereal solution mixture now contains the sulfonamides of primary secondary amines as well as tertiary amine. Now if we add acid, that is called HCl solution, to this ethereal solution, then the tertiary amine react with acid and forms corresponding trialkylated ammonium chloride salt and enters into the acid layer. That is, on addition of ice cold acid HCl solution to the ethereal solution of sulfonamide and tertiary amine mixture, the tertiary amine, we get two layers, that is ethereal ether layer and acid layer. The tertiary amine enter into acid layer due to the reaction of tertiary amine with acid to form corresponding ammonium salt. The ether solution, that is organic layer ether layer, contains the mixture of sulfonamides of primary and secondary amines. Now we have to separate these two layers, that is ether layer and uh, acid layer, by using separating funnel. After separating these two layers, now uh, uh, we have to treat the acid layer with excess sodium hydroxide, which the acid layer which contains ammonium salt of tertiary amine. On treatment with excess sodium hydroxide, we get a pure tertiary amine. Okay, now we separated tertiary amine from their mixture. The ethereal layer or ether layer contains sulfonamide mixture of primary and secondary amine. Now we have to add we have to add base, that is sodium hydroxide, to the sulfonamide mixture of ether solution. Then only the primary amine sulfonamide, the sulfonamide of primary amine, react with base due to the presence of one more hydrogen and sulfonamide molecule. So we get two layers, that is one is aqueous layer and the other one is ether layer. The sulfonamide of secondary amine enter into ether layer. The salt which is obtained due to the reaction of sulfonamide of primary amine with sodium hydroxide enters into aqueous layer. Now we have to separate these two layers by using separating funnel. Now we have to take the ether solution or ether layer which contains sulfonamide of secondary amine. To this ether layer or ether solution, we have to uh, now the heat we have to heat the ether solution which contains sulfonamide of secondary amine. That is, we have to distillate the ether solution. On distillation, the ether gets evaporated, we get only secondary amine sulfonamide. On treating this secondary amine sulfonamide with acid followed by base, we get pure secondary amine. On the other part, we have aqueous acid solution, aqueous base solution, which contains salt salt of primary amine sulfonamide. To this primary amine sulfonamide salt, we have to add some acid, then the sulfonamide undergo hydrolyze to form sulfonic acid and primary amine salt. On treating this primary amine salt with base, we get pure primary amine. That is generally Innsbruck separation. Generally used the separating techniques based on this use of separating funnel. We have to get two layers aqueous, organic or acid or organic. By separating and treatment with suitable reagents, we can get the desired amines, or we can separate the amines from the mixture. This is all about the separation of amines from their mixture. Okay, fine. Next, the reactions involved in the separation method as we discussed in the last slide. Here, this is benzene sulfonyl chloride. It is known as Innsbruck reagent. The benzene sulfonyl chloride undergo reaction with primary amine to form N-alkyl benzene sulfonamide. This N-alkyl benzene sulfonamide, due to contain one more acidic hydrogen, to undergo reaction with base KOH potassium hydroxide to form corresponding salt. This salt can be treated with acid H plus, and due to the hydrolyze of this salt, we get primary ammonium, primary amine salt, primary amine salt, primary amine salt. The primary amine salt on the next step treated with base to get pure primary amine. The secondary amine also undergo reaction with Innsbruck reagent to form corresponding sulfonamide. This sulfonamide don't enter into base or aqueous base layer, because there is no hydrogen on nitrogen atom, so it don't react with base, so it presents in the ether or organic layer only. This sulfonamide solution with ethereal solution is distilled to remove the ether, and then after it is treated with acid followed by base to get pure secondary amine. Here the tertiary amine don't react with the reagent, that is Innsbruck reagent. There is no reaction due to lack of hydrogen. So on treatment with ice cold HCl, this tertiary amine react with acid to form corresponding with HCl, it forms water soluble salt, that is it enters into acid layer. After separation of acid layer, we have to treat it with base NaOH, like, then we get a pure amine, that is tertiary amine, or 3AN, tertiary amine. Okay, this is all about Innsbruck separation, how we can separate mixture of amines. Okay, fine. Next, reaction of amines with nitrous acid. Nitrous acid is HNO2, nitrous acid. Here amines is aliphatic as well as aromatic amines. Generally here the nitrous acid is unstable at room temperature. It is very unstable molecule. So in order to treat the reactant molecule with nitrous acid, we have to prepare nitrous acid during the course of reaction. So the nitrous acid is generally prepared in situ methods, that is in situ method is preparation during the course of reaction. Here generally the nitrous acid prepared by taking nitrate salt and acid mixture. It may be sodium nitrate and HCl or H2SO4. Generally, in the most of cases, sodium nitrate and concentrated HCl solution is used to in situ generation of nitrous acid. This nitrous acid undergo reaction with reactant molecules. Here the reactant molecule is generally they are amines. That is, in the case of the amines are generally two types. So we have to observe the reaction of nitrous acid with aliphatic primary amines. Aliphatic primary amines are generally they are three type aliphatic or aromatic. They are three type: primary, secondary, and tertiary. The case of primary amines, the aliphatic primary amines undergo reaction with nitrous acid, which is produced in situ methods on treatment of sodium nitrate with HCl produces corresponding diazonium salts. That is, reaction of primary amine with nitrous acid produces an unstable diazonium salts. They generally in the first step they produces unstable diazonium salts. These diazonium salts undergo unstable diazonium salts undergo dissociation to form corresponding carbonium ion, that is R plus. The diazonium salt formula is R N2 plus X minus diazonium salt formula. Here it is in the case of aliphatic amines, the diazonium salt found on reaction of primary amine with nitrous acid generally unstable one, so it undergo dissociation to form corresponding carbonium ion R plus. This carbonium ion undergo reaction with the nucleophile present in the reaction mixture. Here the nucleophile is generally only in this reaction is OH minus. OH minus. So on reaction of carbonium ion with hydroxide ion, we get corresponding primary alcohols on liberation of N2 gas. This N2 is removed as N2, stable N2 gas. So that is, if you treat primary amine with nitrous acid, if you get a colorless gas liberated from the reaction mixture, then it is aliphatic primary amine. The aliphatic secondary amine react with nitrous acid to produce N-nitroso compound, N-nitroso derivative. Secondary amines produces N-nitroso derivatives on treatment with nitrous acid. This N-nitroso derivatives or compounds are generally a color compound. They generally contain yellow color and they are oil oily compounds. They are oily compounds with yellow color. These nitroso compounds are generally carcinogenic compounds. That is, they causes cancer causing reagent generally known as carcinogenic agents. These N-nitroso compounds also are the best carcinogenic agents. It is yellow color and oily compound. On treatment of amine with nitrous acid, if we get yellow oily color compound, then we can identify the amine is as secondary amine. Next, the reaction of tertiary amine with nitrous acid generally produces water soluble salts. Generally they produce water soluble salts. On reaction of amines with nitrous acid produces water soluble salts, or we get clear solution, then it is considered as tertiary amine. So based on these three reactions, we can differentiate primary, secondary, and tertiary amines. So nitric acid test generally used to identify amines. Okay, this is all about reaction of aliphatic amines with nitrous acid. Okay, fine. Next, what are the chemical reactions involved in the reaction of aliphatic amines? Sorry, reaction of aliphatic amines with nitrous acid. Here the primary aliphatic primary amine undergo reaction with nitrous acid HNO2 to form an unstable diazonium salt. This diazonium salt generally undergo dissociation to form corresponding carbonium ion. It is unstable one. In the case of primary aliphatic primary, it is diazonium ion. It undergo dissociation to form stable carbonium ion. This stable carbonium ion undergo reaction with different nucleophile present in the reaction mixture. In this specific reaction, it generally produces on reaction with OH minus or OH, or it may form alkyl halide or Cl on reaction with chloride which comes from acid, or it may react with different nucleophiles to form different products. So we get different products in the reaction of aliphatic primary amine with nitrous acid. Here the N2 is liberated as a colorless gas. It is the identification test, that is liberation of N2 gas is specific to identify the primary amines. The secondary amines undergo reaction nitrous acid to form N-nitroso. It is N, it is nitroso group. It is attached to nitrogen, so it is N-nitroso. N-nitroso derivative. It is oil color and yellow color oily compound. It is nitroso derivative is yellow color oil compound. Here the tertiary amine, it is tertiary amine undergo reaction with nitrous acid to form water soluble salts. So reaction of tertiary amine with nitrous acid, if you get clear solution, then it is identified as tertiary amine. It is salt, so easily soluble in water. Okay, fine. Next, reaction of aromatic amines with nitrous acid. Here, as we discussed in the earlier stage, nitrous acid is unstable one, so we have to generate the nitrous acid in situ methods by taking nitrite and acid mixture. Generally, sodium nitrite and HCl is used to generate nitrous acid during the course of reaction. This nitrous acid reacts with amines to form corresponding compounds. In the case of aromatic amines, the aromatic primary amines also undergo reaction with nitrous acid, as in the case of aliphatic primary amine, to form diazonium salts. Generally, the reaction is carried out below 5 degrees centigrade ice cold temperature, under ice cold temperature below 5 degrees centigrade. Here the aromatic diazonium salts Ar(N2) plus X minus, that is aromatic diazonium salts, generally they are somewhat more stable than the aliphatic diazonium salts Rn2 plus X minus, because in aromatic diazonium salts, due to the resonance which is possible in the aromatic diazonium salts, the aromatic diazonium salts are generally stable. This stability is generally below, it is below, only below 10 degrees centigrade. That is aromatic diazonium salts also stable up to 10 degrees centigrade only. Above 10 degrees centigrade, these aromatic diazonium salts also undergo dissociation to form different products. On reaction with water, they may convert it into phenols or into different compounds with different nucleophiles. Okay, that is aromatic diazonium salts are generally stable than the aliphatic diazonium salt due to the existence of resonance in the aromatic diazonium salts in between the diazonium group and iron ring. Okay, fine. Next, here in the case of secondary amines of aromatic amines, that is aromatic secondary amines also undergo reaction with nitrous acid to form an N-nitroso oily N-nitroso derivative, as in the case of aliphatic amines. Aliphatic secondary amines also form yellow colored oily N-nitroso compound. Here also we get yellow color oily and nitrous compound on treatment of aromatic secondary amine with nitrous acid. Okay, yellow color oily compound formation is identification test for secondary amine, whether it may be for aliphatic or aromatic. Okay, next, reaction of aromatic tertiary amine with nitrous acid generally produces para-nitroso derivative. In the case of secondary amine, we get N-nitroso, that is nitroso group, NO group is generally attached to nitrogen atom of the amine group. But in the case of tertiary amines, that is aromatic tertiary amines, we get para-nitroso derivative where the nitroso group is substituted at para position. So it is useful to identify or to differentiate primary, secondary and tertiary amines. That is, the nitrous acid test is very useful to differentiate primary, secondary, tertiary amines from their mixture. Primary amines, in the case of aliphatic primary amines, they react with nitrous acid and liberate a colorless gas. In the case of secondary amines, it may be aliphatic or aromatic, they form a nitroso derivative, yellow color, oily and nitroso derivatives. In the case of tertiary amines, in the case of the aliphatic tertiary amine, they form water soluble salts, that is we get clear solution. In the case of aromatic, the tertiary amines form para-nitroso derivatives. Okay, clear. This is all about nitrous acid reaction with amines. It may be aliphatic or aromatic amine. Okay, next, if you observe the reactions, that is reaction of nitrous acid with aromatic amine. Here the primary aromatic primary amine is, and the best example is aniline, undergo reaction with nitrous acid to form benzene diazonium salt or benzene diazonium salt. This conversion of primary amine into diazonium salt, generally known as diazotization reaction, I will discuss about this in the next video. In the case of aliphatic primary amine, they liberate nitrogen gas and produces mixture of alcohols, alkenes or other alkali halides or anyone based on the availability of nucleophile. In the case of secondary amines, the aromatic secondary amine undergo reaction with nitrous acid to form N-nitroso compound. It is yellow color oily compound, oil compound, yellow color and oil compound. The tertiary amine, that is aromatic tertiary amine, undergo reaction with nitrous acid to form para-nitroso compound. It is para-nitroso, that is para position. The nitroso group is attached to para position, so it is para-nitroso compound. Okay, this is all about the reaction of aromatic amines with nitrous acid. Okay, fine. Next. Okay, thank you very much for your patience. Okay, let us meet in my next video, that is part 4 of amines. Thank you one and all for your patience and watching this video. Okay, bye.